All right, let's take a look at how we can use our trig ratios, this time to find an unknown angle. So we're given the lengths of these sides, but we don't know this angle. Can we do kind of like the reverse of what we've been doing to find what this is? Well, let's have a look, because I reckon we can. In this case, I have a value for the opposite, because if this is my angle, this is the opposite. I have a value for the hypotenuse, but I have nothing for the adjacent. And remember our little memory sort of thing to remember, sine, cos, and tan, so, car, toa. I don't have any info for the adjacent, so I cannot use anything that has an A in it. So I can cross out the two options at the bottom, and I'm left with using sine equals opposite over hypotenuse, because I have an opposite and I have a hypotenuse. So let's do that. I would write it as sine of my angle equals the opposite over the hypotenuse. Now I've got something new. I haven't come across this before. How can I undo sine theta to just get theta on its own? We're going to use a operation called inverse sine. In other words, we take the trig ratio and we undo it. We do the inverse. And here's how we write it. So from this statement here, I'm going to say, well, theta equals inverse sine. So we write sine to the -1. Whatever I had, and I've put that in brackets, the 6/10, just to make it a bit neater. So now this is actually something I can put into my calculator. Let's have a look at how we do that in the calculator. So my question said I had inverse sine of 6/10. First thing I'm going to do is hit the shift button, and then I'm going to hit my sine, because that'll bring up on my screen, as you can see, inverse sine. So if you hit the shift first, you'll get the inverse ratio, and they're printed above the buttons here. My fraction was 6/10, so I'm going to hit the fraction, and I'm going to go 6/10, and hit equals, and I get my value of 36.87. All right, now that we've done that in the calculator, I can see that my value for theta is 36.87, and if I round that to the nearest degree, I get 37 degrees. We've found the unknown angle. Let's have a look at another example. In this case, I've got a 3-meter long ladder leaning up against a wall. The base is 8.8 meters from the ground. What angle does the ladder make with the ground? Okay, so I've got 0.8 along here. I want to know this angle in here. So I'm going to draw a little triangle over the top of this, just so I can kind of visualize something familiar to me, like a triangle that we've been working with. So if I drag that out, I can see that I've got these dimensions. 0.8 of a meter is the length that the base of the ladder is out from the ground. The ladder itself is 3 meters high, and I'd like to know this angle in here, the angle that the ladder makes with the ground. So I'll call that theta. Once again, just like we did in the previous question, I'm going to have a look and see what I can use. I've got nothing for my opposite, so I can't use anything with an O in it, which only leaves me with cos as my only option. So I'm going to write it out. Cos theta equals the adjacent over the hypotenuse. That's what this is. Now remember, we can get theta on its own by doing the inverse of the trig ratio. So in this case, I'm going to have inverse cos to the -1, of my 0.8/3. That I can put into my calculator using the same technique that we did in the previous question, and I get a value of 75 degrees for my unknown angle. Well done, you guys.